Okay, so I have problem one of FRQ 2011, and the given information is x of t is your position function. It's not, the actual equation isn't given, you just know that it's x of t. And then velocity v of t equals 2 times sine of e to the t over 4 plus 1. And they also give you acceleration, which is a of t equals 1 half e to the t over 4 times cosine of e to the t over 4. And lastly, they give you x of 0 equals 2, which is your starting position. And that's important to know for later on. So the first question is part A, which is the speed of the particle increasing or decreasing at time t equals 5.5? So the first thing you're going to do is plug in 5.5 into your velocity function, which is going to give you the speed at that point in time, which is 5.5 seconds. So you're just going to simply plug it in and write in 5.5 for t. And then using your calculator, you're going to find that the answer is negative 0.4353. That's truncated. And then next you're going to find the acceleration, which is the derivative of velocity, which is your rate of change. So how the velocity is changing, which is the speed. So you plug that in, and that's 1 half times e to the 5.5 over 4 times cosine of e to the 5.5 over 4. And when you plug that into your calculator, you get negative 1.358, and that is also truncated. So they ask you also to give a reason for your answer. So if your speed, velocity, and acceleration have the same sign, then you know that the speed is increasing because despite thinking maybe that since it's negative, it's decreasing, just because that's kind of your first impression, it is in fact increasing because they're both negative. So you have to explain. So just written out as the speed is increasing at time 5.5 because velocity and acceleration have the same sign. So that is part A. So the next part is part B, which asks, find the average velocity of the particle for the time period 0 is less than or equal to t, which is less than or equal to 6. So this is just finding the average value of a function, and your formula is 1 over b minus a times the integral from a to b of f of x dx. And we're finding this velocity on the interval 0 to 6. So it's just 1 over 6 times the integral 0 to 6. And I'm just going to write v of t dt. You get 1.949, and that's truncated. The next part, part C, they ask for the total distance traveled by the particle from time t equals 0 to t equals 6. So we know that distance is just the absolute value of an equation because you want to take into account the distance traveled in the positive or forward direction, and you also want to take into account the distance traveled in the negative, or you might say like backwards direction. So you have to take the absolute value. So you're just going to take the integral from 0 to 6, the absolute value of the velocity equation, because when velocity is integrated, you get position. So v of t dt, and again, when you plug that into your calculator, you get 12.573, and that is also truncated. The first thing I'm going to show is the integral from part C, which is the distance. So you're going to go to the math button and go down to integral, enter that in, and then from 0 to 6. And then here you need absolute value of the velocity function. So you go again to math, but then go under the numbers tab and click the absolute value, and it shows you the absolute value sign, and then enter in your velocity function, which is 2 times sine of e to the x over 4 plus 1, and then d of x. And you get the answer. So the last part of this problem is part D, which is for the interval 0 to 6. The particle changes direction exactly once. Find the position of the particle at that time. So how you're going to go about doing this is finding the critical numbers of the velocity equation. So, which is where the velocity equals 0. So the easiest way to do this is on your calculator, which I will show later, and it's very simple. But when you do that, you get v of t equals 0 when t equals 5.1955, and that is a rounded value, but in your calculator you can store the actual value to get a more exact answer later on. So you know that this is the point when velocity changes, which basically is just showing how the speed is increasing, and then stops at 0 and then goes back. So then the way to find the position at that time is you're going to take x of this value, so 5.19552, and again, there will be a more exact answer later on in the calculator. This is where you're going to use this piece of information, which you do 2 plus the integral from 0 to this value, which 5.19552, of v of t dt. And you're going to do adding 2 because that is your starting point, so you have to start from 2 and then add on whatever value you get here. So that ends up being 14.134 truncated. Last thing I'm going to show how to do on the calculator is finding the 0 of the velocity function. So you're going to, as I've done here, plug in the velocity function into the y1 section, and then click the graph button, and that will give you this graph. And then to find the 0, you're going to hit the second button and calc, and then hit 0. And then it asks for the left bound, which you put on the left side of where the 0 is, and then right bound, same thing for the right side, and then it says guess, and you hit enter again, and it gives you the 0, 5.1955223. And then for storing this value, you're going to just hit clear, and then hit alpha and x, and enter, and it gives you the value. And then the easiest way to start is just hit enter again, hit the store button, and then alpha, whatever you want to put. So I'm just going to store it as A, enter, and it'll give you that number. After you have your stored value, to do the integral for part D, you're just going to do 2 plus, and then the integral, which is under math. And then 0 to, we stored as A, so alpha A. And then input your velocity function, which again is 2 times sine of e of x divided by 4 plus 1 dx. And when you enter that in, it will give you your answer.